Hi. In this episode, we're going to discuss how you can add interactive features to your virtual assistant by using Rasa custom actions. Custom actions allow you to write custom Python scripts that run on behalf of your users. And this just opens up the doors to many features for your virtual assistant. Before diving into the full syntax, though, it's good to take a step back and to understand how these custom actions fit in the general picture. Very, very generally, there are two main things that you really want your virtual assistant to be able to do well. It needs to be able to understand what the user wants from the assistant, and then it needs to generate an appropriate response. And responding appropriately sometimes means that we only need to send back a message to the user, but there are many other tasks that the assistant might also need to be able to perform. For example, the assistant might need to send an email or make a calendar appointment on behalf of the user. That means that we might also need to fetch relevant information on behalf of the user, which in turn means that we probably will need to have a way to communicate with a database or a third-party API. And when you think about it, you might also consider that we need to make specific calculations sometimes on behalf of the user. And for all of these scenarios, I hope it's clear that we need more than just static responses. Preferably, we're really looking for a way to write custom code for all of these use cases. And in this video, we will explore how to use Python to handle these situations for us. In Rasa, we call this custom actions. And the important concept here is that we're able to run custom code to fetch information and complete tasks. And again, we're doing this because this will open up a lot of features for our virtual assistants. Now, again, in the big picture, where do these custom actions fit? Because when a user is talking to the assistant, Rasa open source is making sure that we apply natural language processing techniques to parse relevant information from the conversation. And this would include things like the right intents and the correct entities. If we think about what custom actions should be able to do in this conversation, though, as a service, then there are different concerns. After all, custom actions don't need to do any machine learning. That's what the Rasa open source already takes care of. Instead, we're likely more concerned with how we're connecting to a database or to an API. And that means that these custom action services are probably more about fetching the right information and getting the security credentials right. That also means that there's a natural separation of concerns here. We want Rasa open source to be able to communicate with the custom action service, but we wouldn't want these two services to become a single monolith. And this is an important distinction to make. It means that we will need to run two services on our machine if we want to use custom actions. But it also makes it possible to scale the assistant more flexibly in a production setting. You can increase the number of workers for the action service without having to double the workers for the Rasa open source service. Having mentioned all of this, let's now have a look at what the code for a custom action might look like. What you see here is a very basic example of a Rasa custom action. And there's a few things to observe. A Rasa custom action is implemented as a Python class. Rasa provides a library called Rasa SDK that makes it easy for you to define a custom action, but you will need to follow a predefined API. So let's dive into this. You're looking here at a class definition. And in particular, this class definition is importing the action class from the class SDK, and the class that we are going to be referring to is called Action Hello World. And note that it's inheriting from the action base class. From here, let's note the two methods that are implemented. The first method, called name, gives the name to this custom action. And this name is quite important because it's this name that we will be referring to in our stories, domain, and rules.yaml files. The second method, called run, contains the Python code that we want to run when the custom action is actually triggered. And it's here where you're free to write any custom Python code that fits your use case. The method will receive information from the Rasa NLU service that you can use for your custom Python code as well. And you're also able to send relevant information back to the user programmatically. Now, let's zoom in on what this run method receives. You'll notice that the first thing it receives is a dispatcher object. And this is an object that allows you to send messages back to the user. Besides this dispatcher, your custom action also has access to a tracker. And this tracker is an object that contains relevant data that was extracted from the conversation so far. And you can imagine that this includes the predicted intents, entities, but also slot values. Lastly, the custom action will also have access to the data defined in the domain.yaml file. It's less common to write custom actions that heavily rely on this information, but it's good to know that this information is available to you. With this general API overview out of the way, let's dive into a more tangible example. Let's say that we want to make an assistant that is able to listen to an input like, "Hey, what time is it in Amsterdam right now?" and then answer it appropriately. In order to do this correctly, we need to configure the assistant to do a couple of things. The first thing is we have to be able to detect Amsterdam as an entity, and this has to be passed on to a custom action that can then use the appropriate library to give back the appropriate timestamp. So what I'm going to do now is just show you a live example of this, and I'll discuss how I've implemented this behavior. So here is a Rasa project. The project that you're looking at is the Rasa init project. And what I've done is I've made a few changes to show how a custom action would work. The first thing that I did is I went to my nlu.yaml file and I added an entity as well as an intent. The intent that I added is called inquire time, and there's a couple of examples here where the user is asking about what time it is, and the user is also able to ask about what time it is in a certain place. I also made a lookup table over here with a couple of examples of these entities, which will later be used by a regex entity extractor. The idea is that whenever this intent is spotted, that then a custom action is triggered. And I've declared this behavior in my rules.yaml file. I added a rule over here that basically states that whenever I see the inquire time intent, that then this specific action tell time needs to be triggered. And this is the custom action. Before we can go ahead and use the custom action though, it needs to be properly configured in our domain.yaml file as well. So what I did is I added the inquire time intent to my intent list over here. I also added a entity for place. And at the bottom, I have also made sure that the action tell time action is configured as well. As always, you want to make sure that you double check the spelling. It'd be a shame if you made a typo here, but having all of this configured, we're nearly there. The only extra thing that we need now is to make sure that we also detect the entities appropriately. And I've configured my config.yaml file appropriately for that. I have a regex entity extractor over here that is using lookup tables. So that means that with everything configured, I should now be able to have a custom action, and this custom action will be able to receive entities whenever our machine learning pipeline finds them. Now, with all of that done, let's now move to the actual implementation of the custom action. You can find the custom action inside of this actions folder in the actions.py file. And here's what the code for a custom action looks like. I am importing a couple of dependencies. The main thing that's important is that we observe that I'm importing this action class from the Rasa SDK, and I'm using that below here. The actual action itself is implemented over here as a class. And you'll notice that the action tell time class over here is inheriting the action class that I imported earlier. This class has two methods that are important. The The first method is the name method. And you'll notice that the name method returns the name of this action, and you'll also notice that there's a correspondence between all the configuration files we've seen earlier and the name of this action. Again, it's quite important to pay attention to spelling errors here. Given the name of the action, we now need some sort of a function that will run on our behalf. And that's the run method that we have over here. We see that the run method receives a dispatcher as well as a tracker as well as a domain, but all the logic that we need to handle the telling of the time action is declared here. Specifically, I am asking the tracker to get me the latest entity value for the place, and if that's unavailable, then I'm going to return the value none. The idea here is that the custom action doesn't just have to give back the appropriate time, it also needs to be able to fail elegantly if there's no place entity detected. So if there is no current place detected, then I am sending back a somewhat general message. I am calculating the UTC time, and that's what I'll be sending back. The way to send this message to the user, though, is to use this dispatcher utter message method. And you'll notice that the dispatcher that I'm using over here is the one that I'm also receiving over here. When we reach this point, we can safely assume that there is a place detected. But in order to calculate the time, we are making use of a database of sorts. I am checking the city database. In this case, the city database really is just a dictionary, but we can pretend like it's an actual database. Both the dictionary and the database might have a missing value. And that's another one of these edge cases that we have to consider. So if the current place isn't in my database, then I send another message back to the user that might be able to help. I'm telling the user that I don't recognize the current place and to check whether or not it's spelled correctly. And again, I'm using the dispatcher for this. Finally, if the place that's detected is in our database, then I have a very specialized message for the user here. And again, I'm sending that back via the dispatcher. Note that in this case, I am using the arrow library to handle a lot of my time zone logic. And that's also what's nice about these custom actions. As long as you make sure that it's properly installed and imported, you can use whatever tools you like inside of these custom actions. What I would now like to do is give you a demo of this, but before I can run the demo, there's one final thing that I still need to do. As you might remember in the beginning of the video, I mentioned that there's this separation of concerns between the Rasa service and the custom action service. And because there's a separation of concerns, I will also need to run this service before I'm able to use custom actions inside of Rasa. What I also need to do is I need to make sure that the Rasa service can find the custom actions. And in order to do that, we need to configure one more thing in the endpoints.yaml file. Since we're only doing the demo locally, the only thing you need to do is uncomment the lines that you see over here, where we configure the action endpoint. If we were running the action service someplace else, we might need to replace this URL with the URL where we're hosting the action service, but this should already be sufficient. Given that this is now configured, we will now move on to doing a small demo. I've just opened up two terminals, and note that in both terminals my virtual environment is active. I've already trained a Rasa model, so what I'm first going to do is call Rasa run actions. This is going to run the actions service, and that means that the custom action defined here is now running as a web API, which means that I can now use Rasa shell to communicate with my custom action. So I should now be able to say hello. It says, hey, how are you? And I should now also be able to ask, what time is it? It's now giving me the UTC time, but I should now also be able to ask, what time is it in Amsterdam? And what time is it in London? And we can see that we are getting different times back. So the custom action that we've defined over here is handling all the logic on our behalf. So that's great. We've just seen an example of a custom action We've seen how you can use a dispatcher to send messages back to the user, and that you can use a tracker to fetch relevant information from the conversation. You might have noticed though that we've gotten this return statement in our custom action that currently returns an empty list. The idea here is that there's a distinction between messages sent back to the user via the dispatcher and other events that might influence the conversation. One of such an event is the setSlot event. It's this event that allows the assistant to store information about the user so that it can be used later. So let's do one more example, but this time we'll use the setSlot event to store information that will be used later in the conversation. So let's expand on the previous example. And we'll do that by allowing the user to declare where they live. The idea is that if we know where the user lives, the user is able to ask what the time difference is between where they live and in another city. In this example, we will build two custom actions. One will be setting the slot for where the user lives, while the other one will be used to fetch the relevant information.
To add the new behavior, I've made a few changes. First and foremost, I have added some new training data in my NLU file, and the main thing that's important is that there's now an intent where a person can say where they live. This intent is used in my rules.yaml file as well, and I have also updated my domain.yaml file. The main thing that's different is my actions.py file. And if we have a look at the action that needs to remember where I live, you'll notice that the main thing that's different is that we're now actually setting a slot over here. We are no longer just sending messages back, we are actually emitting an event here as well. The way this works is that I am using the slot set event, which is imported from the Rasa SDK. And I'm saying the location slot needs to be filled with the current place. And the current place is, again, something that I'm retrieving out of the entities. However, because I now have a slot that might be set, I'm now also able to use that slot in another action. The action that handles the time difference action doesn't just get the entity for the current place that we're comparing against, we are also fetching the location that is in the location slot. And again, we're doing fallback scenarios here to make sure that we fail elegantly, but now we have an action that is using not just an entity, but also a slot as well. So let's do another demo. Now I have a new terminal window open here, and I am running my Rasa action service. And what I'll do now is, instead of using the basic Rasa shell, I'm going to use Rasa interactive. The reason why I'm doing this is because this also gives me a view in the slots that are being set. Let's also make this a bit bigger. And there we are. Let's start by typing hello. It's detecting greet, which is correct. It wants to reply with utter greet, that's correct as well. And we are now listening. I could now tell the bot that I live in Amsterdam. When I run this, it is detecting the where I live as the intent, which is correct. And it's also detecting that Amsterdam is an entity of type place, which is also correct. Note that at this point in time, the location slot is empty. But right now we are just before we are running the remember where action. If we run this action, we now see that there's a slot set event happening, and we can also confirm that the current slot value for location is indeed Amsterdam. So we indeed now have a custom action that is able to set slots. I will again say that this is correct. And if I were now to ask, what is the time difference with London? It would now detect that inquire time difference is the intent, and again it would pick up that London is an entity, which is also correct. It will now want to run the action time difference, which is the action that will tell me what the time difference is.
And it's able to correctly tell me that there is indeed a 1 hour time difference between Amsterdam and London. And this is nice because that means that we're able to not just use the entity that we're detecting here, we are also using the slot that was set here in an action later. So let's wrap up. In this video, we've discussed how you can have your assistant run custom Python code on behalf of your users. We refer to this feature as custom actions. And the idea is that you can use this feature to fetch data from a database, communicate with a third-party API, but you can also use it to customize the messages that we send back to users programmatically. In this video, we've discussed the most general kind of custom action, but Rasa also offers more custom actions that will help you collect information from users. These custom actions can be used together with Rasa forms, and we are going to be discussing these features in the upcoming videos. I hope you'll stay tuned for those.